move to the second part of this 0 to 04. We will build another plot based on the formula, which is describing the projectile motion. So it's like this way: you throw something to the sky, and then there's like a stone, for example, and this stone is reached those highest the point, then back to the ground. So then they have this curve we call this the projectile motion. So and then we will split this into two parts, and one is we draw on one single this curve, and then we draw the several to do the comparison. And then before we go to the coding is in this mind map, just to let you know is we have already put the code related to the every subchapter based on our learning. Like the last video is we built one basic universal gravitation, and then we did some adjustable the parameters as the second one. So these two are linked to this Newton's law of universal gravitation. And for this one is first we will generate some equally spaced floating point number so that we can use that to make those time and SR the equally the spaced list. And then this we will draw one the trajectory, and then we draw three trajectory with the different initial inputs value. So and if you read this, I think this normally is on the grade 7 or grade 8 physics classes. They will tell you this one after this Newton's law learning. So you sit on point A and throw something to point B. So you will have our initial the speed and the initial this angle. So we call this initial speed is the velocity. So you have that those velocity, and also you have this angle. We call that theta. So these are the two the unknown the inputs we should have, and then through this calculation we split our velocity on x-axis and y-axis. So we will call this u split to ux and uy, and they based on this cosine. The u times cosine theta is this the x the axis the velocity, and u times sine theta is this y, the uy. So now we have these two velocity separately, and then we that is only the initial velocity is u, and if this speed is this object or the matter come to this highest point, the uy will decrease to 0. But we assume this us is keep constant. So ux is still moving to here. And then when this object is starting to drop, when they can reach the B, so we will calculate that will be the negative uy. So just a different direction, but from this absolute value, this uy is the same to this ui. So that is just the two parts of this curve. And then here you may review that afterwards, but the logic is we will calculate this velocity change based on our formula. So Vy is changes through this minus gt. T is time and g is our constants for this gravitational acceleration. and t is the time at which the velocity is measured. So we will have a very tiny interval of t, then you can draw quite a smooth this curve. And then when we have every time we have the velocity, then we can starting to have this distance. Then this s is the traveled distance. We also have this y is the velocity times the t. So u sine theta times t, and the gt also times t. So that is the part is we will have those way to make this vertical distance traveled this calculation, and we put the calculation is we will have some boundary value. So boundary value is when this object reach to the highest point. That is the sy is going to the maximum, and at this time is the t, the velocity in y, which means is vy is 0 because it's starting to have no the upper the speed go to the keep further upper. So through that is we put this the u sine theta is going to 0, which is vy is going to 0. And then we can calculate t. T is then that is the time duration is when this object reached the highest point. Then through this t, we can have the those results for the t flights, and then this we can use that to represent over the x this value and y value. So those are the simple logic is how you structure this formula, and then this you have your formula to have this coordinated value in either y and x. And then firstly is we need to generate our equally spaced floating point number. So let's create our the first code. This is a part of this drawing strategy. So we directly go to this one. So it's a 0, 2 and 0, 1. So it's drawing trajectory. So that is 1. So we call this py. And let's copy this here. So what the purpose? Purpose is to draw the trajectory of a body in projectile motion. So first is let's back to here. Well, we need to generate equally spaced floating points numbers between two given values. So that is our list that we need to do. So that is def French start final increment. So that is just as the starting the loop, final, the ending loop, and step. So, and we have our numbers equal to our empty list. Then, while star not reach final, so we use a while loop. So numbers dot append start, and then star. You can use the star plus 0, C increment. Yeah, these are the allowed syntax. then we return numbers. So we return this finished list. So this one is we used here. And then let's go to, so we have this one is I solve the list, and we're starting to have over from mat plot. If you find that can be auto the complete, just try to choose so that you can prevent the typing error. So import pyplot as the plt. So this running from this import this as is similarly is as import this as. So that is the same way. So then we also need to import mass because we have a sine and cosine those functions. And then you can see here is similar is what we have done. Normally we need to define the draw graph function is xy in 2-dimensional space. So plot xy, and the last will be draw. So the show. So we don't make show here because we will draw our multiple points. So x label, x coordinate, y label, y coordinate, LT title. Yeah, you can use double quotes if you want. So projectile motion of our, maybe not a ball, so just our object. We don't define this must be a ball, so you should not use any specific name. So, and we have this draw trajectory. So for when you draw this, you should have 2 inputs. These 2 inputs, as we analyze the formula, is just the initial the velocity is not in this xy, it's just in one the angle. So and then you should have that angle is the theta. So we have these 2, and all the rest of the results can be calculated through these 2 inputs. So now we can start to see theta is mass dot radians. So when we calculate the sine or cosine, we need to convert this theta to the radian, those the coordinates. So that is the way you need to pay attention. And we gave the constants g is the 9.8. So this constant is small g because in the physics the small g and the capital G has a different definition. So we here I don't use the capital letter to refer the constants, but it is whenever you can, that will be good, so that people can know this G is not a variable. So time of flight, yeah, we have this T flight is 2 those velocity, mass, sine, define G. So that is this one. So we have calculated this one. So we can directly use this T flat because we don't have a dot. So also those the different size. So we use the underscore. That will be better. So 2 times u times sine, but if you want to use sine, is you should have mass dot sine theta. Now theta is in the radians, so theta divided by g. And then we find time interval. So intervals equal to French. Now we use this French. So French is we give the input is 0, t flat. So t flat is the maximum of the t. So then with the 0.001. So using this French, the function is we generate one list of all the times interval. Now we have this time. We will later use that as the x-axis. Now we will calculate the y. So and list of x, or calculate this point. So points x and y. So and put that into those the coordinates space. So we list of x, y coordinates. So make them empty first. And how we can input that is this x is the u times cosine theta t. So it's this one. U cosine theta t is this sy. So and as x is the just this here, u cosine theta t. As y is u sine theta t minus half gt square. So that is the formula. So we will just put in those formula into our computer. So now you can see here where we will have our this matching. So every t with the interval, we will have our x and y pair. So that is this t. So for t in intervals, x dot append u times mass dot cosine theta times t. And similarly, is y is append u times mass sine theta times t minus 0.5 or half times tg times t times t. You can also times t square. That is fine. So and after that is what we will do is we will load this draw function, draw graph. Now we almost finish. The only thing is we will give those inputs, and then we will have this finally show. So through this draw, we already have the plot. But now is if name is check that equal min. It should be the small case. Then we will try. So we will see is whether it have a value error. So try is we give the u and the theta. So u should be a float. So enter float input. Enter the initial velocity meter per second. Then we have the second is the theta. So let's minimize here. Then you can see O. So theta is longer. So float input. Enter the angle of projection in degree, and we will convert that to this. Let me see here is where we convert that. It's here, convert to the radians coordinates. So then we have this one, and we try is accept value arrow. Then if that is value error, we will print you entered an invalid inputs that I cannot convert that to the float. And else, try except else. If not value error, that means then I will start to draw trajectory with inputs u and theta. And after that is I will show that. So I think is everything okay. Now input this. Let's see what were inputs. 25 meter per second, and then we give 60. So now I got this one. As I mentioned, this initial the point is now looks better than this plot graph in the book. So it's already optimized a little bit. But this shape is exactly the same. And let me show here if I put another. So if I have maybe 100, the faster, and I have the not so like 60 is just half. Then this well, you can see it looks the same, but it's because this y-axis or y-coordinate is in the different unit. Now its highest is more than 120. Earlier is just go to the 25, and here is also is getting the more the long to the distance. So that you cannot see the difference because they make that is compressed. So looks like it's they are same. And then this we will use this to draw some different lines in the same the coordinates. Then you can starting to see the comparison. So comparison, let's do. The comparison is just the if name is here. Let's put that. Second is comparing trajectory. So the difference is not change on this one, but only the changes to these mean parts. So we will give our different list. So but they are both in the theta is the same. So let's rename this. We don't have this try needed. Then let's comment that. And what we will give is, yeah, let's see, list of 3 different initial velocities. So U as a list now is equal to 20, 40, 60, and give the one define the theta, and for U in U list, we will load this draw trajectory and give the U theta. So it's very easy. And the difference is we need to add a legend. So PLT legend. You can put that if you don't give those code, just 20, 40, 60 is enough. Let's see. So and then plt.show. Let's run. Yeah, you can see here. I got this legend. So when you have a smaller the this velocity is not go too high, so high, and if your the velocity is increase, it's get higher and the more even far away. So that is one the change, and you can also change on the theta. So let me go here. So if I put these comments and then different initial angle. So let's see, I only put this as 40, but I have a list for angle now. List. Maybe I put this 10, 30, 50, 70. 90 is we'll get our up or down, and then this yeah, let's see, I will also have a 1, 0 to the another direction. So then I will have 2 theta. In theta list. Now my U is just like this. So plot is also I got this copied. Let's see. So what I got now. So you can see this is 1, is 10, 30, 50, 70. This is 90 is very interesting, and this 110 is the just the same as this 70 because they have the same difference to this 90. So then you have the more colorful the way to show the based on the different input parameter. So I hope is you got some ideas on how to draw the trajectory, especially is how you can prepare those formulas to generate needed points in the 2-dimension the coordinate space. Yeah, and thank you for your watching till now, and we have done the those knowledge parts. Within this chapter, we learned the basic of creating the graph, and we show the single side of value, how to create a multiple plot on same graph as what just practice now again. And we have the customized the graph, and also we use the graph to analyze the temperature, some physics, the method. So in next chapter, we will use the Python to start exploring statistics. But before that is from the coming videos, we will work together to do some challenges. So there's, let's see, so how many challenge on this chapter? So it's again 5. So we will see how this will be conclude based on our current knowledge. So see you in the next video.